This is Math 2020 in 10 minutes or less. I'm James Munro. Let's go. 1a. The centre is at 3, 4 and there's a corner at 1, 5, which is a displacement of -2, 1 as a vector. If we rotate that vector by 90 degrees, then we get the vector -1, -2. And that displacement away from the centre at 3, 4 gives us the point 2, 2, which is another corner of the square, and the answer is D. 1b. If we multiply out these brackets, we get e to the 2x minus x squared, and we can recognise that as the derivative of 1/2 e to the 2x minus x cubed over 3. If we put the limits in, we get 3e squared minus 5 all over 6, which is option D. 1c. We have 1 minus 4, which is minus 3, and then 9 minus 16, which is minus 7. And this pattern continues. It gives us an arithmetic progression with first term minus 3, common difference minus 4, and there are 50 terms in this sequence. Doing the sum of that arithmetic sequence gives us the final answer minus 5050, which is option E. 1d. If I use cos squared is 1 minus sine squared, then this becomes a quadratic in sine x. If I complete the square, then I can find the maximum value when sine x is 1/3 is 13 over 3, which is option B. 1e. The gradient of x squared at x equals a is 2a, and if I send that through the point a squared, then I get the equation of the tangent as y equals 2ax minus a squared, which crosses the x-axis at a over 2. The area in the question is the integral of x squared minus the area of the triangle made by the x-axis, perpendicular to the x-axis from that point, and the tangent line. So I need to integrate x squared between 0 and a, and then subtract the area of that triangle. I get a cubed over 3 for the area under the parabola, and a cubed over 4 for the area of the triangle, to give me a final answer of a cubed over 12, which is option C. 1f. If I factorise everything inside the brackets, I get 2 to the 8 times 3 to the 4 times 5 squared times 7. If I take out the log base 10 of 7, then I can spot that log base 10 of 2 times 3 is log base 10 of 6, and pull out 4 times log base 10 of 6, and then spot that log base 10 of 2 times 5 is 1, and pull out 2 times log base 10 of 10. That leaves me with 2 log 10 of 2, and so the answer is C. 1g. The turning points are at x equals 1 and x equals 3, so if I take the derivative of this cubic, then it should be 0 when x is 1 or x equals 3. Plugging in 1 and 3 to the derivative of this cubic gives me two equations for a and b, and if I solve these simultaneous equations, I find that a is minus 6 and b is 9. Now, sending this curve through the point 1, 2 gives me the value of c, that's minus 2. And finally, checking the value at x equals 3 gives me the value of d. I find d is minus 2, so the answer is B. 1h. If we sketch the derivative of each of these functions, then we find that the derivative of graph A looks like graph E, and the derivative of graph B looks like graph C. So D is the odd one out, and it must be a plot of h of x. 1i. This is the sum of the terms of a geometric progression, and the sum to infinity is 1 over tan x minus 1. If we set that equal to tan x and solve the quadratic for tan x, we find two possible values of tan x, but in fact we need 1 over tan x to be between minus 1 and 1 so that the geometric series converges. If we do that, then we get one remaining value of tan x, so the answer is B. 1j. When r is very small, a is 0 and b is 4 minus pi r squared. That rules out option C. On the other hand, when r is very big, a is pi r squared minus 4 and b is 0, and that rules out option A. If we also notice that this sum can never be 0 because we can never have both of these areas being 0 at the same time, that rules out options B and E as well, so the answer is D. Question 2, part 1. 1100100. Part 2. G of f of g of f of 1 is 100. Part 3. In binary, f adds 00 to the end of a number and g adds 1 to the end of the number. 200 ends in 000 in binary, which we can't make. Part 4. Write the number in binary. It must be made of 1s and 00s. For every 1, write down f, and for every 00, write down g. Part 5. Consider u k plus 2, which is elements between 2 to the k plus 2 and 2 to the k plus 3. Those have either come from applying f to an element between 2 to the k plus 1 and 2 to the k plus 2, or by applying g to an element between 2 to the k and 2 to the k plus 1. If we add together the number of elements in those ranges, we can find the number of elements u k plus 2 as the sum of u k plus 1 plus u k. Part 6. Notice that sk is u0 plus u1 plus ... plus uk. If we sum the previous equation over different values of k and use the fact that u0 equals 1 and u1 equals 1, then we can rearrange for the equation here. Question 3, part 1. Set y equals 0 and we get a is minus 1 and b is 1. Part 2. If we complete the square, then we get one solution for y precisely when y is 1/2, so delta is 1/2. Part 3. Where the curve exists, we have y as 1/2 plus or minus the square root of some function of x. That gives us symmetry about the line y equals 1/2. Part 4. These points have y equals 1/2, so x cubed minus x plus 1/4 is 0. Part 5. Suppose this cubic factorised as x minus alpha, x minus beta, x minus gamma. Then if we multiplied that out, we'd get an x squared coefficient of minus alpha plus beta plus gamma, but our cubic has no x squared coefficient, so that sum must be 0. Part 6. We know the centre of the circle is at alpha plus beta over 2, 1/2. If we write down the equation for the circle and substitute for y minus 1/2 squared, we get a cubic equation for x. Now this cubic has an x squared coefficient of 1, so the sum of its roots must be minus 1. We already know two of the roots, they're alpha and beta, so the other root must be minus 1 minus alpha minus beta, which is equal to gamma minus 1. Okay, pause the clock. This question has a typo in it, and I'm really sorry about that. The definition of an odd function has too many minus signs in it, and if that misled you and meant that you couldn't do this question, then we're going to try and mark very carefully and fairly so that you can still get credit for the work that you wrote down. On with the question. Question 4, 1a, an even function has reflectional symmetry in the y-axis, and an odd function has rotational symmetry of order 2 about the origin. Part 1b. Think about a tangent line. If you reflect that line in the y-axis, then you'll get a line with the opposite gradient. But if you rotate it by 180 degrees, you'll get a line with the same gradient. Part 2a. The area A of minus theta is congruent to the unshaded triangle in the diagram. So adding them together, we get the isosceles right-angled triangle with short side 1 and area 1/2. Part 2b, write that area as the sum of two triangles, add their areas together to get 1 plus tan theta all over 4. Part c, my sketch looks like this. Part d, this has rotational symmetry of order 2 about the point 0, 1/4. Part e, this symmetry means that the derivative is an even function, so the second derivative is an odd function by the first part of the question. Putting 0 into an odd function always gives you 0. Question 5, part I. If the 15 sunny days come first, then Miriam eats the most possible sweets. A quick arithmetic progression sum gives 345 sweets. On the other hand, if the 15 sunny days come as the last 15 days, then she eats the fewest sweets possible, and that's 120 sweets. Part 2, we have to sum a couple more arithmetic progressions, and we get the same numbers as before. Part 3, the effect of this swap is that Miriam eats an extra sweet because there's a sunny day earlier, but Adam also eats an extra sweet because the rainy day comes one later. Part 4, yes, start with the sunny days at the end and use the swaps to move them back in time. Adam and Miriam's totals start the same and increase by 1 for each swap, so the totals stay the same as each other. Question 6, part 1, there's only one tennis ball and k stockings, so that's k choices of which stocking ball Santa puts the tennis ball in. Part 2, there are n tennis balls and only one stocking, so Santa must put all the balls into that stocking. Part 3, this splits the possibilities for g and k into two cases. In the first case, Santa has to distribute m-1 balls between k children, whereas in the second case, Santa distributes m balls among k-1 children, giving nothing to the first child. These are all the possibilities for g and k, so we should add together these two expressions to get g and k. Part 4, use the previous expression to express g75 in terms of g of smaller numbers, apply the facts that g1k is k and gn1 is 1, and we find that g75 is 330. Part 5, let's make Santa give one tennis ball to each child. Now Santa's got 2 tennis balls left and 5 stockings. Any possibility from g to 5 is a possibility for splitting up these remaining tennis balls in a way that satisfies the requirements of part 5, so the answer is g25, which is 15. Question 7, part 1. Lots of possibilities. We could join the first row to itself and get CCA, CCB, CCCC, or we could join the first row to the second row and get CCC, A, CCB, 5 Cs. Part 2, you can't get to AB because you've always got at least one C, and you can't get to things like CBCAC because B is always on the right of A. Part 3, yes. For example, join the first row to itself 5 times and the second row to itself 4 times, then join those together. Part 4, no, because the first block of C's can only be at most twice as long as the middle block of C's. The original rows satisfy this, and any join satisfies this too. Part 5, write down the basic rows, then join the second one to itself. Do it again, then do it again. Join the two basic rows together, then join that to the third row, join that to the fourth row, and then join that to the fifth row for the goal row. Part 6, if you're not joining a basic row each time, then you can do a longer sequence by joining the things that your non-basic row is made of. If you join a basic row each time, then the number of C's in the middle goes up by 1 each time, so you need 15 joins in the slowest possible sequence. That was Math 2020 in 10 minutes or less. There's more information on Math on www.maths.ox.ac.uk/r/mat. Thanks for watching.